so we're starting chapter 4, and the first part of this chapter is very easy. Today's assignment is extremely easy, stuff that you probably had in 5th grade. It's a chunk of it. And the second part is a little more challenging. We do introduce the proofs again, but the proofs, in my opinion, are easier. They're a little bit more directional, and usually the grades are given, so don't panic too much. Don't forget that your GeoTown project is due Tuesday. We'll also be at the quiz on Tuesday. Okay. So anyway, all right. So we're starting with the first lesson, and it deals with classifying triangles. And triangles can be classified in two ways. They can be classified according to their angles and according to their sides. So really, you can have like two names. You can have an obtuse isosceles triangle. Okay. But to classify them according to their angles, you have the acute triangle. And in an acute triangle, all three of your angles are acute, which is less than 90 degrees. A special type of acute triangle is an equiangular triangle. And if you look at the word, equi means equal, and angular means angles. So equiangular is equal angles. So all three of the acute angles are equal. Then you have the obtuse triangle. In an obtuse triangle, you have one obtuse angle, an angle that's greater than 90 and less than 180. And then your right triangle obviously has a right angle, okay, one right angle. All right, so that's how you classify them according to their angles. So here's a couple of questions. You just classify each triangle as acute, equiangular, obtuse, or right. And the first one we want to look at is triangle PQR. Okay, so if we look at that and we look at the angles, well, how would we classify this triangle? Obtuse, because we have two acute angles here, but then this one, if you added those angles together, it would be obtuse. So we have an obtuse triangle here. Okay, and then PQS. What kind of triangle is PQS? Okay, it's right. It has one right angle. Okay, so it is a right triangle. Good. All right, so then we're going to classify them according to their sides. Okay, when you classify them according to their sides, you can have equilateral. Again, we have equi means equal, lateral means sides. Okay, so equal sides. All three sides are equal. Then we have the isosceles. In the isosceles triangle, you have at least two congruent sides. At least two. And since it uses the word at least two, your equilateral triangle would also be considered isosceles, yes? Because it has at least two congruent sides, right? But it is more specific because all three sides are congruent. That's why it's called equilateral. And then we have the scalene, where it has no congruent sides. They're all different lengths. Okay, so here's an example. It says, if M is the midpoint of JL, classify the following triangles as equilateral, isosceles, or scalene. Now, the first thing it tells us is that M is the midpoint of JL. What can we get from that? Well, that is true, but that's not what we get from the midpoint. That would be segment addition postulate. Okay, that JM is congruent to ML, right? That's what we get from M being the midpoint. Okay, and since JL is 1.5, what does that make JM and ML? Makes them 0.75, right? Now, we also see that we have two congruent sides here, right? And so if these two sides are congruent, KM and LM and MJ are congruent, what's going to be true about all three? They're all going to be 0.75, right? They're all going to be congruent to each other. Okay. All right. So, with that in mind, I want to look at triangle JKM. Okay. So, if I look at triangle JKM, what do I notice about it? What kind of triangle is it? It's equilateral. These two are congruent, and this is 0.75, so this is 0.75, and this third side is 0.75. So yes, it is equilateral. Okay, and the other one was KML. What kind of triangle is that? Well, look right here. We've got two sides here that are congruent, right? So it would be isosceles. Is that what you meant to say? All right, now what if I ask you to classify this green triangle according to its angles? What would you call it? Obtuse. So really this is an obtuse isosceles triangle, right? But it just asks us to classify it according to the side, so that's all we need. All right, let's go to the next page. It says find x and the measure of each side of equilateral triangle RST. Now it says it's equilateral, so that means that all three of these sides are equal. It says that RS is x plus 9. It says that ST is 2x, and RT is 3x minus 9. Okay, so we need to find x and the measure of each side. What am I going to do to figure out x? Any two number of sides? Right. You pick any two sides because they're all the same. So you want to pick x plus 9 and 2x? Okay. So we're going to pick x plus 9 and set it equal to 2x. And if I solve for x, I end up with x equals 9. And since it's equilateral, my RS is going to be equal to my ST, and it's going to be equal to my RT, and they're all going to be equal to what? 18. So if I plug 9 in anywhere, I end up with 18. Okay. Last one. Now in this one it says find the measures of the sides of triangle DEC. Classify the triangle by the length of the sides. And it gives you ordered pairs for each one of the vertices. Okay? Now in order to classify it by the sides, what do I need to know? I have to know the length of the sides, right? Which means I'm going to have to use the distance formula. The distance formula. Okay? I'm going to use the distance formula. Now, sometimes it helps to graph it. I don't really think it would help so much to graph this one because I can see in looking at the x and the y coordinates, none of them are the same, so I don't have any horizontal or verticals. Okay, so I'm just going to draw a picture and label here, and then I'm going to use the distance formula. Remember I told you guys that formula wasn't ever going to go away? I wasn't lying. Okay, so remember the distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, so let's do DE first. Alright, so I'm going to subtract my x's, 3 minus a negative 5 quantity squared plus, I'm going to subtract my y's, 9 minus 3 quantity squared. That gives me 8 squared plus 6 squared. 8 squared is 64 plus 36. That's 100. So the square root of 100 is 10. So my DE is 10. Alright, so it's going to do that 2 more times. Now let's look at EC. I've got negative 5 minus 2 quantity squared plus 3 minus 2 quantity squared. That gives me negative 7 squared plus 1 squared. What's negative 7 squared? 49. Positive 49 plus 1. And that ends up being radical 50. Now, I'm just comparing the length of sides, so I don't necessarily need to get the exact answer or the estimated answer, so I'm just going to leave this as radical 50. Because now I'm going to look at DC, and if I can show DC as radical 50, it's going to be isosceles. If it's something other than radical 50, it could be something different. If it was 10, it would be isosceles also, but if it's just some random number, it would be scalene. Alright, so last one is DC. And again, I'm going to subtract my x's, 3 minus 2 quantity squared, subtract my y's, 9 minus 2 quantity squared. So I end up with 1 squared plus 7 squared. You should start seeing something here. Because over here we had negative 7 squared plus 1 squared. Probably these are going to be the same, yes? So this ends up being 1 plus 49 which is rather thin. So, what kind of triangle is this? Isosceles. Good. Okay, so we talked about how to classify our triangles by the angles and by the sides. How do we classify them by angles? What are the possibilities? Obtuse has one obtuse angle. Acute, three acute angles, right? One right angle. What was the other one? Equiangular. What's special about equiangular? Three congruent. Yeah, all the angles are equal. And we'll actually learn that if it's equiangular, it's also equilateral. More than that. Here, maybe tomorrow the next day. Okay, and then we classify them according to their size. What are my possibilities there? Equilateral, all the sides are equal. Isosceles, at least two sides equal in isosceles, right? And scalene, no congruent sides. Okay? Alright, it's a pretty easy day. You guys have quite a bit of time to work. A lot of time. Look, you guys made it to the finish line. Okay? Your assignment's on page 241, I believe. It actually says 240 up there, but I think that's right. 241. 16 through 46 even, 49 through 52, 57, and 60.